In today's video, we will solve logarithmic equation using properties of logarithms. I have two examples here. The first example I have is log base 3 of x plus log base 3 of x minus 8 is equal to 2. To start solving this equation, I have to remind you about the product of property, where it says if you have log, gonna write it here, log base a of m plus log base a of n is equal to log base of a m times n. I will use this property to do the next step for this equation. This is equal to log, since they have the same base, 3 of x times x minus 8 equal 2. Here I want to solve for x, of course. That means I have to get rid of the log. To get rid of the log, I have to rewrite this equation in exponential form, which means here I have, this is the base, and this is my exponent. Which means this is equal to what? Is x minus 8 equal to the base 3 raised to the power 2, or 3 squared. Now I'm gonna just simplify x and FOIL. X squared, this is minus 8x is equal 3 squared is 9. I'm gonna subtract 9 from both sides. I'm gonna have this plus 9 minus 9, it's 0. X squared minus ax minus 9. For this side is equal to what? It's equal to x minus 9 times x plus 1 equal to 0. I can write x squared minus 8x minus 9 is equal to x minus 9 times 4x plus 2. Now here I have either x minus 9 is equal to 0 or x plus 1 is equal to 0, which means x is equal to 9 or x is equal to minus 1. Now I have to check those solution, which means I have to replace it in my equation. I will see if they will verify the equation. I'm gonna start with x minus 1. For x equal to minus 1. My equation becomes log 3 of minus 1 plus log base 3 of minus 1 minus 8 is equal, I'm trying to prove that is equal to 2. That's why I wrote here a question mark. Since I have here log base 3 of negative 1, I cannot take a log of a negative number, which means xa equal to minus 1 cannot verify my equation, which means x minus 1 is excluded from the solution. Now I will try with x equal to 9. I will replace x equal to 9 on the equation. X equal to 9 means my equation becomes log base 3 of 9 plus log base 3 of 9 minus 8 equal to 2. Question mark again. I have to prove this. Log base 3 of 9 is 2 plus log 3 of 1 is equal question mark of 2. We have here log base 3 of 1 is always 0. If you have log of any base of 1 is always 0. This is equal to 0, which means I have 2 is equal to 2. This is true, which means my solution for the first equation is x equal to 9. I will do the same thing for the second example. Second example is log base 4 of x plus 6 minus log base 4 of 2x plus 5 equal to minus log base 4 of x. For this part, I will use the quotient property, and for this part, I will use the power property, which means this one becomes log base 4 of x plus 6 over 2x plus 5 is equal to log 4 of x minus 1. And this is log 4 x minus 1. I can write it 1 over x. X plus 6 over 2x plus 5 is equal to log base 4 of 1 over x. Now I have to use the 1-to-1 property, where it says if you have log a of m is equal to log a of n, then m is equal to n. Since they have the same base, m is equal to n. Now here I will use it in this step. We have x plus 6 over 2x plus 5 is equal to 1 over x. Now I see I have here a quotient equation. I will solve a quotient equation. I will have x, I'm gonna continue on this side, x plus 6 times x is equal to 2x plus 5 times 1. I'm gonna distribute. We have x squared plus 6x is equal to 2x plus 5. I will add minus 5 for both sides. Minus 5 for both sides. Plus minus 5 plus 5 plus minus 5 will give me 0. 2x is equal. Here I will have x squared plus 6x minus 5. Now I will subtract minus 2x from both sides. I will have minus 2x minus 2x. X squared 6x minus 2x will give me plus 4x minus 5 is equal to 0. I have to factor this equation. This becomes x plus 5 times x minus 1 equal to 0, which means either x plus 5 is equal to 0 or x minus 1 is equal to 0. Here will give me x is equal to minus 5 and x will give me x equal to 1. These are my two solutions for this equation. I have to check if this solution verify the equation, which means I have to replace x minus 5 in the equation and x equal to 1 on the equation. X equal to minus 5. Log base 4 of minus 5 plus 6 minus log base 4 of 2 times minus 5 plus 5 is it equal to minus log base 4 of minus 5. I see here I have a log of a negative number. As I said before, we cannot evaluate a log of a negative number, which means x minus 5 is excluded from the solution. Okay, I'm just gonna write here x is minus 5 is excluded. Now I have to check for x equal to 1. I'm gonna replace it straightforward here. It's much easier for me. X minus 1, I'm gonna have 1 plus 6 over 2 times 1 plus 5 is equal to 1 over 1. 1 plus 6 will give me 7. 2 times 1 is 2 plus 5 is 7. 1 over 1 it's 1. 7 over 7 it's 1, which means 1 is equal to 1. And this is true all the time. Which means my only solution I have for this equation, number B, is x is equal to 1. This is the end of this video. Thank you for watching.